Over the years, I've crimped and terminated countless RJ45 plugs onto various network cables, and I've used a variety of traditional closed-ended plugs, pass-through or easy plugs, and even modular plugs with a load bar. The thing is, all of those methods require you to purchase a crimping tool, and the good quality ones can be pretty expensive. That's fine if you're making up a lot of cables on a regular basis in your line of work, but if you're just an enthusiastic DIYer or only have one or two ends to install, then it might not be worth the investment. That's where Toolless RJ45 plugs come in. Although they're much more expensive per plug than the sort you need a crimper for one-off jobs they could actually work out much cheaper because of not needing to purchase an expensive crimping tool. Plus, they're also much easier to use for beginners. So to get started, you'll just need a length of network cable, probably either CAT5e, CAT6 or CAT6e. It will depend on your use case, but we won't get into the differences in this video. The tool-free RJ45 plugs, there are a few different types available, including these fancy ones with die-cast zinc housing, but I'll be using these cheaper plastic ones in this video. A pair of wire strippers, cheaper more basic ones will also do the job, as would a pair of nail scissors and a steady hand, but a pair like this works best if you have one and is a very worthwhile investment for any DIYer. A pair of snips or flush cutters, again a good pair of sharp nail scissors might do the job if you don't have any snips or wire cutters handy. And finally, a network cable tester, whilst not absolutely essential, is a very, very good idea both for peace of mind and for diagnosing any problems. There are purchasing links for everything you'll need, including the tool-free plugs themselves, in the video description. Start by taking your wire cutters and cut however much cable you need for the cable run you'll be working on. Be sure to leave a generous amount of excess because a couple of centimeters will get chopped from either end, and also because it's always better to have a little bit too much rather than end up with a cable run that's too short. Network cable consists of 4 twisted pairs of wire, so 8 wires in total. CAT6 cable usually also has a loose plastic core running down the center to reduce crosstalk between those 4 twisted pairs. Each pair is color-coded, with one of each pair being a solid color, and the other pays homage to the awful joke I made in another network cable tutorial video on this channel. First, place the 2 parts of the boot onto the cable and slide them down for later. Then, strip about 2 centimeters from the end of the cable, being careful not to damage the conductors inside. Snip off the plastic crosstalk separator and the ripcord thread that both run along inside the cable, and then untwist all 4 pairs of wires. The outer jacket that you just stripped off can be useful to help with that. Straighten out all 8 wires by pinching them tightly between your thumb and the back of a pair of pliers or a screwdriver, then running them along like this. Next, we'll arrange the color-coded wires into the correct places inside the plug. There are 2 main wiring standards for network plugs, TE568A and TE568B. The only difference is the greens and the oranges trade places. There are specific and historic reasons for having those 2 standards, as well as why you should always use either one or the other, but I won't get into that in this video. The key importance is that the wiring standard used is the same on both ends of the cable, so if you're just making a length of cable for yourself at home, then it really doesn't make any difference, as long as you use the same wiring standard on both ends. I tend to use TE568B because it's the most widely used. If you're adding cabling to an existing setup or replacing a faulty end, then make sure you use whatever standard is already in use at the location to make things easier for yourself and any other engineers who might do work there after you. Unlike with other types of RJ45 plug, you don't need to memorize wiring diagrams or arrange the fiddly wires into the correct order and feed them into the plug. You just match each wire up with the corresponding color on the little load bar, and you can see on the top there that it tells you to put the greens on the left side and the oranges on the right side for the B standard, and the other way round for the A standard. So, feed the oranges and greens all the way through the holes on the top row of the load bar and pinch the bottom ones into place down below. Make sure the load bar is as close to the end of the outer jacket as possible to minimize the length of untwisted wires before they enter the load bar. Then take your flush cutters and trim the wires so that the ends are flush and not poking out past the plastic ends at all. Notice how the top row, underneath here, ends up being longer than the bottom row. Then you just need to align the grooves on the load bar with the other half of the plug and press down firmly into place. Slide the boot over and then tighten up the nut and you're done. It really is that simple. Do exactly the same thing on the other end of the cable and it should just work perfectly straight away. However, it's a very good idea to test it first with a cable tester to make sure it's all wired up correctly and to prevent any problems occurring, not just with what you're connecting the cable to, but potentially with your whole network. The best network cable testers look something like this one, and they run a continuity test to ensure all 8 connections are good on both ends and wired up in the correct order, 1 to 1, 2 to 2 and so on, before awarding your handiwork with a pass. This one will even tell you where you've gone wrong if you have, as well as working for crossover and shielded cabling setups. The great thing about these tool-free RJ45 plugs is that they're also reusable, so if you've made a mistake, you can just take them apart, fix the issue and reassemble without wasting an end. You can also get much cheaper network cable testers like this one though, which work by sending a pulse down each wire in turn from the master to the remote. You should see the sequence going from 1 to 8 on both ends, and when it does, you know that the cable is working perfectly. If you get a sequence like this, then you know you've made a mistake somewhere. If it's a long run and both CAT5e and CAT6 cable are good for 100 meters, then you can separate the master and remote parts of the cable tester and put one at each end of the cable run to test it.